Arrays. We'll start out with the definition of an array. An array is an ordered collection of items. Okay? An array is an ordered collection of items. So think of an array as having a bucket of items, whether it be candy, right? Whether it be toys, whatever it is, that bucket has a collection of items. Okay? Swift, with being a type-safe language, we're able to say what our array holds, right? Explicitly. Or the compiler could infer the type of array it is. We could explicitly say our array only holds strings, or integers, or doubles, or users, our custom data type users. So that's what an array is. It's a collection of items. It's ordered. Whatever order you put it in, that's the order it maintains. Let's see how we initialize arrays. As I said before, we could type annotate an array with what type, data type it will hold. We could start off by having a mutable variable here, call it bucket list. Use type annotation with the colon. And here we're specifying the type. So an array begins with an open square bracket, right? That's type annotating the array, open square bracket. Whatever type you want to define here, you put it in the square bracket. In that case, I want to have an array of strings. This here with the colon, open square bracket, string, close square bracket is type annotation. So using type annotation, we are declaring an array of type string. Right? So here we declared a variable. We called it bucket list. As we started, we said a bucket could have toys in it. Here we just call it bucket list. We type annotated, and we have square brackets embedded with the word string, the data type string. That now is an array of strings. So far, so good? Great. So here I have my bucket list. It's mutable, so I could go ahead and add items to it. In that case, I will add some destinations, France, Australia, so in the square brackets, I have to put strings in there, right? I have to put strings. This is a string. This is a string for France, quote in quotations. That's a string. That's valid. It's an array of strings. So in the array, every item is separated by a comma. Currently, how many items do I have in that array? I have 2 items. I have France, I have Australia. Right? If I try to put 78 or 187 here, the compiler is already mad at me. Right? Let's see what the error is. Cannot convert value of type int to expected element type string. I can't do that in Swift. Yes, sir?
So, because I was confused when you started quoting like France and Australia, because we declared it using the string. So it's expecting the string now because
we type annotated it. it's expecting a string here because we typed annotated it. We said we guaranteed our array, as Christian is pointing out, we are guaranteed that our array only holds strings. So now our user is trying to put an integer in there.
So it would recommend this friends also quotes.
Those are strings. So those are valid. Everybody sees Christian's suggestion here, or rather observation, right? France is a string, Australia is a string. What data type is 187? It's an integer. Is it valid here? No, this does not compile. Only strings could go here. I could put the 187 in quotes, right? But where is 187? That doesn't, right? But that would be legal, but again, 187 is not a destination. But this would compile, because now it's a string. Everybody with me? The quotes make it a string, exactly, as Zora is pointing out. So here we type annotated our bucket list, and be very careful here. This is an array here. If you see that on the question, is that an array? Right? Compiler also says no. So it has to be within square brackets. That's the syntax for an array. Great, so we have destinations here. What else we have? South Africa. Aruba. Okay, cool. So we have our bucket list. Matt, you have a bucket list place to go? Oh, I saw your hands. Where's your place? Where do you want to go? Brazil. Where do you want to go, sir? Japan. Okay. 2020 is a good year. We got the Olympics. We got the Olympics going. Great. So here we're able to declare a bucket list array of type string. We're able to initialize it with values. Let's go ahead and print out what our bucket list is. So print bucket list. Run the playground. And we have our array, our full array of collection items printed out. So we have France, Australia, South Africa, Aruba, Cozumel, Brazil, and Japan in there. So far, so good. This is good. We could also, this is initializing. Great. I could also count the items in the array. Anybody remember the syntax? How do I count? How do I count? Isn't that a brilliant property name? Okay, using the keyword count, right? So print. That's where naming your variables or anything is very helpful to the user. Because if you tend to forget, oh, how do I just said it, how do I count? That's the name already, right? The name is in the variable. So here I will say, there are string interpolation countries on my bucket list. So there are string interpolation bucket list dot count, and go ahead and run that playground. There are 7 countries on my bucket list, right? So we are able to declare, initialize, and count how many items we have in our array. So far, so good? Okay. Keeping on topic with initialization, we could also initialize an array using a repeating initializer. Let's see what that looks like. So I could have doubles here. Start out with the keyword array. On array, the array type itself, it has its own initializers. So if we type out the keyword array, and we have an open parens, and we scroll down to repeating, you could create an array with some repeating value, and say how many of those you want. That might be a use case in some scenario where you want to create some empty array with default values. For example, here, make sure we select in repeating, the one that says repeating. Press enter. And for our repeating value, which is our default value, we say 0.0 because we have doubles here. And we want 3 of those arrays. Okay? So if we go ahead and print it out now, print out our 3 doubles. We have an array with 3 values in there, right? So we have a default array with 3 values. We could go ahead and use it whichever way we want. Just keep in mind we have that at our disposal if you want to have some array with some default value. The default value could be any value you want to start with. Okay, so I will copy this here and just paste it so we have what the output looks like later for our playgrounds. Great. Let's look at accessing. Let me get a header here. Accessing arrays, which we saw briefly over the last 2 days, but we'll see it again. So here we have accessing values inside an array. Great. We'll create a new array. We'll call it planets. In this case, we are not using type annotation, and Swift will do the inference for us. So we'll start out with Mercury. We'll stop here and see what type it is. So anybody remembers how to see the type using the keyboard? Option click on the variable name, correct? So go ahead and option click on planets. What type is it? It's an array of strings, correct? It's an array of strings. It has the square brackets. Inside of it has the word string. Yes, sir.
I have a question about repeating.
Okay.
Is it possible to initialize an array with more than one repeating value? Let's say you want 0.03 times, but then you want.
I mean, you can, but the best way might be using a for loop in that case. Like using a for loop, and on the increment, you just change the value every time it goes through the for loop. Because the repeating only gives you access to one default value. Yeah, very good. So I would use a for loop for that. Okay, so good. So now everybody comfortable that we're able to say it's a string array, correct? Yes, sir.
How would you compare this with like tuples that can store multiple things and it doesn't matter what type it's in?
Okay, great. So a question was, one was asking, how does that compare? How does an array compare with tuples, right? Tuples, we have a tuple here. Fellow, for example. We have one who is a fellow. Already, we see the difference between a tuple and an array, right? Based on the syntax. We have open parens, close parens, correct? All right, let's keep going. So the tuple here, we have a name. The name is 1. And we have a cohort. Cohort is, let's keep it as a double, 6.3. And we have a hobby. What's your hobby, sir? Gaming. Awesome. So here we have a tuple. If we option click on 1, we see it's a tuple. It has 3 values. It has string, it has a double, and it has a string. Everybody sees that? Okay. So tuples are great when you're trying to group. Example, you have an object, or 1 in that case, and 1 has those attributes, right? I would call them attributes or properties. 1 has a name, a cohort, a hobby, right? A good use case for that would be that here, where you're creating a fellow called 1, And you could put, now you can't, I can go ahead and make multiple ones and iterate through it. I have to put it in an array, right? To make it flexible, if I want to say go through one or go through a set of tuples following that description and see who's in 6.3 like we did last week, I would have to put all in array, right? I would have to say create a fellows array and put one in here, for example. And I could create a different fellow. Shania. Six 6.3, assuming you 6.3 is fine. What's your hobby? Music? Yeah. Art? Yeah. Yeah, all of them? Yeah. Okay, cool. Music. Okay, so we have two fellows. We put them in an array of fellows here. Fellows, fellows, fellows. We have Shania. Great. The difference we'll see with arrays and tuples, Shania right now, you can't add a next value on Shania. If I say, hey, I have Shania here, I want to add a next fellow, I don't have access to that. I only have access to what Shania is. On my array of planets, I could add more planets in there. Okay? I could add my Venus, my Earth, my Mars onto that array. Okay? Arrays, again, is a collection of similar items, ordered items, right? So now I could have a planet of strings and put all my 8 planets in there. Sorry, Pluto, but I could put my planets in there. But with the tuple, it comes in very handy if you want to have, again, as I said, an array of fellows, and maybe you want to have a switch statement on it and see who has a hobby of gaming, right? And invite them to game night, right? So that tuple would be a good use case there. And as we see with functions, when we go into functions, if your function is returning more than one value, a tuple would be very good for it. Because you could have a tuple of the values you want to return. And a tuple would be perfect for that. When we get to functions, we'll talk about it. But we haven't seen functions, but actually write our own functions. But if your function is returning more than one value, you could return a tuple. Because a tuple is one or more items. Right, one or more items here, I could return a tuple and say 0.1, yeah, but we'll get into functions later. But as we said, very good question from Juan, what's the difference? One of the differences is, as I said before, with our array, we could add multiple arrays, like I could have an append my next planet to my arrays, as we'll see in the example. But on one, I can't do that. I have what I have. Right? I have 3 values. I can say add a 4th value on it. I could change the values. I could change what one's name is, but I can add a 4th property on it. Yeah. If I want to change, I'm okay right now because it's a var. A var is mutable. I could change. Yeah. Mutable? Yeah. So I could change it. Yes? Only strings in that case. We have our planets, it's only strings. It becomes very complicated, not highly suggested. JavaScript has it all the time, where you could have an array of different values. In that case, I would have an any. My type would be any. Then when I'm taking items out of my array, I need to find out what type it is before I use it. Because if I'm taking out a string and trying to add it, my app will crash. Right? I have to do a lot more fidgeting there. You can do it, but the language provides us this tool, create the thing of the same type. But you might have a use case where you want to have any type, you could do that. Okay? But not highly used, especially in Swift. Cool. So either you start off with like an array of strings, array of ints, that sort of thing. Cool? Very good. So let's keep going. We have, so this was a tuple example here. This is tuples. And here, let's continue with our array. So array of planets. Great. So we have our Mercury. We have Venus, the planet we live on, hopefully. Mars, Jupiter, Saturn, cool. So we have our planets. Sorry for the ninth planet here. We'll put our ninth planet in its own array. What's that? That's fine. Pluto needs love. All right? Cool. But here we have our 8th planet. Sorry. We got to go back to elementary school and be like, hey, my 8 was correct on that exam. Cool. So we have our planets here. Let's start accessing it. Say I want to access Earth, right? What would be the index of Earth? Everybody? Kelby, what would be the index of Earth? 2, right? We all agree it's 2? Because we do not start counting from 1, right? Like we learned, again. We start counting from 0 when we're referring to arrays. So index 0 is Mercury, 1 Venus, 2 Earth. Everybody with me? Okay, so if you've seen the number visually, yes, it's the 3rd one here, but 3 minus 1, okay? 3 minus 1, 2. 2 is the index. So let's go ahead and see what Earth looks like. So let 3rd. And we use our planets. So you use whatever array you want to access. Subscripting here is the square bracket. And the element we're after is the 2nd index. So accessing. Using subscripting. Subscripting is square bracket, open square bracket, and element name. Okay. So this here is referred to as subscripting. The way you access the array is called subscripting, as we saw yesterday. If I was to access the last element, how would I access it?
As well as the second element?
I'm sorry? If I want to print out Neptune, how would I go ahead and do it?
No, I'm asking, you want to print out both Earth and Neptune or
Just Neptune. So actually, let's print out Earth first. Sorry. So let's print 3rd rock from the sun, and we'll continue here. Okay, so we got Earth. This is great. But what if I want to print out Neptune? Hands? So Luba? So what am I typing out? I would just say last planet here, call it a variable, and planets. What am I putting in the subscript syntax? Minus dot count? Oh, planets, sorry. So planets, so Luba is saying planets that count. Why minus 1? What's that? Why minus 1? It's good, but why minus 1? Because the index is starting from 0, right, everybody? Right? So our count here is 8 in that case, right? But if we try to access, let's go ahead and access it. So I do planets at 8. What's going to happen to our application? Execution was interrupted, right? Fatal error. You'll see this one once in a while, frequently, especially when you just start. Index out of range. Fatal error means our app crashed. right? It's dead, fatal, right? So fatal error, index out of range. We're trying to access an index that does not exist. Index 8 does not exist. Even if we do have 8 objects in the array, but using 8 is invalid. That's why Luba was saying we have to minus 1, right? So minus 1 here, we run the app again. It gets us, we don't print it out, but it's here, sorry. So we get our Neptune. Did everybody get that? Right? So we have to minus that 1. We have to take account that we started from 0. Yes, sir.
You should count the difference between count minus one or the pop last function.
Well, pop last removes. We haven't gotten to pop last yet.
So pop last will remove
Remove the last item. We haven't seen pop last. Let's get there. We haven't gotten there yet. Right now, we're just trying to access, not remove. Access. Show us what that value is. Okay, so here we have to do the minus 1. And again, it will come up a lot. We'll try to access some array, see some index out of range, go back and see what you're doing. Are you minusing 1? Are you trying to access something that's not valid? Everybody with me? Okay. So let's do this here, and let's have a print statement. The last planet in our solar system is last planet. Right? And for up here, we could say our home planet is this. Let's get some more space here so we could all see what's happening. Let me drag this guy down and let me play the playground. Okay, so we see our home planet is Earth on line 41, and we see that the last planet in our solar system is Neptune. So we were able to access values in the array using subscripting, right? So this is subscripting here, as we saw, and this is also subscripting. Subscripting is the way you access elements in the array. So for practice, let's go ahead on our own computers. Let us print the second to the last planet. Right? So create some variable, call it second to last. And continue the code. And print second to last planet is second to last. Second to last planet. We know what we're doing, correct? So we're writing code to print out the second to last planet. Let me just put this so the errors go away here. We'll take 30 more seconds, and we'll get a volunteer to come up. Actually, I called somebody. We haven't heard some voices. We haven't heard some voices. So if you haven't heard, if you haven't been helped, or you'll get called on. Yes, I am, for sure. Let's do it. Let's do it. Thank you. So let's get. Actually, yeah, let's do it. But I'm not going to show it on the screen right now because we're recording. Um, Kelby, you've been called before. Yulia. Cassandra. Cassandra. All right, cool. So Cassandra will complete the code so we get the second to last planet getting printed. And run the playground. Second to last, right? That's what we have there. Thank you so much. Cool. So, explain to us what's happening here before you run away. Yeah. Everybody with that? So -1 gets us the last element. If you want to get the second to last, we -2, right? And so forth. Everybody with that? Okay, cool. Question? Yes, sir.
So as opposed to indexing, the count in your array can change if it's still always pointing to the second to the last one.
Yes. It's more dynamic as opposed to hard coding it. Yes, yes, yes. So Greg brought up a point. I'm assuming you put in 6. I'm assuming you put in 6 for your answer. No, what was your answer? Did you put count or?
Yeah, did that count?
Oh, okay, yeah. So the count keeps it more dynamic, right? As opposed to hard coding the value, because your array could change.
As opposed to pointing to the index.
Exactly, exactly. In that case, you want to use planets.count -2. Again, you probably want to make sure there's more than 2 elements in there, because your app could also crash. Everybody with me? That's where it gets really tricky as we're doing whiteboard questions or any question. You can't assume, right? Like, hey, you have to protect yourself against the actual array. Does the array have more than 2 elements? If it does, you could do -2 on it, right? And get back the first element in that case. But if it has 1 element and you try to -2, you're going to get an index out of range. Everybody? Okay. So the more we learn, the trickier it gets. If that makes sense. Yes, sir.
Can you slash this out? I end up missing.
Oh, that's fine. Let me do that right now. Sure. Copy. Slacks. Yes. Check the count, like have an if statement, like if count is whatever, then go ahead and do it. Yes. Yeah, check the count first before you go ahead and minus the thing. Yeah. Okay, so code and paste it in here, and we'll say arrays version 1. Send to Mr. Joshua. You're welcome, sir. Any other questions? Okay, we'll get a next volunteer. While we attempted our own computer, we'll say print the middle planet. So print the middle planet, go ahead and do that. This time, I'm not gonna give you any variable or any print statement, but declare a variable, declare a variable middle planet, for example, and print out its value. Yes, sir. It doesn't matter, just whatever the middle is. So divide the thing by 2, whatever that is. Okay? Yeah. So middle planet, hint divided by 2, whatever that is, and then give us that. Yeah, that's just like divided by 2, and whatever that gives you back. Cool? In that case. While I get my next person ready. Aha. Uh-huh. 30 more seconds. Okay, Mr. Oscar. So declare a variable middle planet and print out its value. Subscript, square bracket. And print it out there.
Just print.
Yeah. Print out middle planet. And use string interpolation actually. Oh, 1 second. And then great. Thank you, sir. So here, Oscar took planets that count divided by 2, and he got us our middle planet. Yes, we have 8 planets. There's no exact middle there, but it gets us that middle index. Okay? Awesome. Okay, let's go to talk about some properties and methods on arrays. I will grab a header. So new header, we have properties and methods on arrays, or some. Can go through all of them. All right, cool. So think, for now, think of a property. I'll just put the because again, we haven't spoken about functions. I'll just give us some context here. Property, think about it like a variable on a type, on an object. Example, array, that count. And when we say method, we're talking about a function. So think about it like a function that runs on an instance. Don't worry about all those things. We'll talk about functions. A function that runs on an instance of an object. Example, our array. Actually, let's use planets. Planets dot append, for example. We'll talk about append, so we could put append here. And here, this is a method, a function. And here, let's change array to, say, planets to get better context. So we talk about properties, we talk about methods, we talk about functions. But it's hard to show those topics without introducing what the thing is. So a property is some sort of variable on an object. For example, we have our planets array. On arrays, you have a dot count, right? We seen that yesterday on strings. So a property would be a count, right? That would be an example of a property. A method, which is a function, but here we mention it as a method. A method is, for example, planets.append. We'll see what append does, but it adds to that planet. Okay? So when I talk about properties, some properties and methods on arrays, those are available for us. As a matter of fact, let's go to documentation to see what it looks like. Do we remember what documentation is? When you want to ask for something, what do you shout out? Help, right? So most applications on the Mac, a good application, should have like a help tab in the menu. So Xcode has help here. Do we see help? Do we see help? Help, right? So we have help, we click on help. What's the first result we see? What's the first result we see? What is this first result here? What do we see here? What's this result? Developer documentation. Documentation implies where the thing got documented. Somebody wrote some code, they published it, you the user. Most likely you want documentation to know how to use the thing. You got a refrigerator, it's fancy. How do I turn it on? There's a manual, hopefully, right? Unless you get it on Craigslist and there's no manual, right? But there's a manual here. We refer to that as documentation. It tells us how to use the API. So click on developer documentation. And yesterday we were able to go through some of the APIs we've seen over on the right side. But we're able to say, hey, if you want to quickly go to a specific API, you could go to the search box here. Everybody sees where it says search documentation, top middle. Here I will enter, what am I interested in? Array, right? I'll type in array, I'll press enter. And my first suggested result is array from the Swift standard library. Everybody sees that? That's what I'm interested in. I'm writing Swift, right? Swift standard library, the standard library. Think about it like going to your neighborhood library and look up what array is. This is what that is. So I click on array. And most of what we initially spoke about is here. It says, let me slowly go up here. It says an array is an ordered random access collection. An array is an ordered collection, okay? An array is a struct. We said we'll talk about structs and how they're value types. It gave us an overview of arrays. Arrays are one of the most commonly used data types in any app, right? Which makes sense. You want to have a collection of fellows in your app. Like, for example, I have the app that I made here. I'm using an array with fellows, right? I'm able to do actions on that array. I'm able to say shuffle my array and give me a random fellow so I could call on. That's the power of an array, right? I could tell my array, sort yourself alphabetically. So I get Adam, right? I could make it sort backwards. So I get 0. Arrays are very powerful. And in the array documentation, it tells us or shows us all the methods we have. We have repeating, which we saw earlier. We created a repeating array with count 10. So if you count, you have 10 zeros here. Accessing arrays, we saw that. We'll see, actually we haven't seen that again, but we saw it before using a for loop. Is empty, is my planets empty? We have, in here, that would be a property. So anytime you see a dot followed by some name, if the name doesn't have parens, what is it? A property. If it has parens, it is a method or function, okay? I'm not gonna get ahead of myself here and show us optionals again because it's beautiful once you know how to use it, but at first it's like, what is this? What's happening? But here they're using optionals to see if there's a first value, right? My suggestion is please read over that part here where it says use first and last in prep for tomorrow's optional class, right? But here they're using optional unwrapping, they're using optional binding to say, hey, if you have a first and a last, well, you should get me the items and print it. We'll go over that again tomorrow, but today I do not want to lose us too quickly. But this is optionals here. So if you say dot first on any array, it returns you an optional value because it might not exist. This is the best way to access the first value in an array, using an optional. Because if you say my array is 0 and there's nothing, what happens? It crashes, right? But if you say my array dot first returns an optional, there's no way your app crashes. So it's better to use optionals there, right? In Objective-C, we didn't have optionals, so we'd have to say array.count equal to whatever, right? But with Swift, we have optionals. If planets.first has a value, use it. Yes. So as Mr. Jahid is saying, it does nothing, it comes back nil. In that case, we could have an else over here to capture that. Yes, sir.
So is like my array dot first equal to my array index 0?
We'll go over it tomorrow. But if you could like read ahead with optionals, that gets a bit, like we saw last Friday, optionals is like new. Like programming is new already, now optionals again, like what is all that stuff? Like read it on the train, because the documentation, as I said, is offline. So read it before class tomorrow, and we could go through some examples using arrays and how to access them. How to access that first, that last, is optionals, how to use it. Cool? Good, good, good. Now let's keep going. Adding and removing, we've seen this here. We have students, and we assign it Ben, Ivy, and Jodel. We've done that. We haven't seen a pen. We'll see what a pen does. Add to my planets. Say if I want to add Pluto again to our planets. Come back, Pluto, right? But the documentation gives us everything we want. If we keep scrolling down, let's keep scrolling. The most interesting part of the documentation is where it says topics. Everybody in topics right now? If we scroll down where it says topics, as we saw yesterday with strings. So strings, topics, was similar to this. Here we could create an array using some initializer. We'll talk more about initializers. But we used this initializer before today. We used it today. We said, hey, create me an array repeating 0.0 and the count. It tells you what it is. It creates a new array containing the specified number of a single repeated value, single. So as Cameron was asking earlier, in that case, we could only do a single value. If you want to make it more dynamic, you could use a for loop. Every time I go through the for loop, make the value different. That value, you could grab it from an array. You see how arrays are powerful? They're very powerful. Inspecting an array, we did count before. We'll see what isEmpty looks like. Accessing elements. Adding elements. That we'll always add elements. We'll always append. Combining arrays. Right? The quickest way to combine an array, just use the plus sign. You have two arrays, same type. My array plus my other array, you have a combined array. We'll see how that looks like. Removing elements, we'll go over remove. But the documentation shows you everything. That's what I'm saying. There's no way in any course you could go through every function or every method and every property on an API. The array API is vast, as we saw. Every year, there's like new things coming out. 2 years ago or last year, they added shuffled or random element on an array, right? We had to do more work before. Now we just have that at our disposal. Go ahead and shuffle my array. Finding elements, we'll see what contains. We saw contains. Contains are on many types, by the way. Like you could even have contains on a range. If you have a range, you could say, does my range contain some integer? So this is contains here. You have contains on string. Does my string contain this character? Does my array of planets contain this string? Yes, sir. Yes, exactly. So contains is like throughout the language, which makes sense if you want to find something especially. So here we see first, right? Do we see first on my screen? Do we see first? What type does it return? Some optional element, right? As we said earlier. It's powerful. This is deprecated. Be careful. Don't use index of. It's deprecated. The API tells us don't use this. It's going to disappear pretty soon. What we use first index. We used that yesterday. We have max, we have min. Get me the maximum value in my array. If I have some array, it's like 10, 5, it's scrambled, you could say array.max. It gets you back that maximum element in the array. Prefix we saw yesterday, drop first, right? Drop last. There's so many cool functions here. Map, there's map, but we'll look at map when we start talking about functions. You have an array, map it, map returns you some transformation. A very powerful functional language. Compact map, I give you a set of objects. If they're all integers, great, return me them. But if there's invalid integers in that array, do not return them. That's what compact map does. Shuffle shuffles the collection. So I have shuffle on my fellows app here. Shuffle my array. Get me a fellow. You could have a deck of cards. Shuffle my cards, right? I don't want to pick the same card all the time. The game is not that interesting. Okay, great. So that's the documentation. We saw how that looks like. Very good. Let's go back. And I will close that out. So now we know how to access the documentation, correct? And we also know we could go online to our browser if we rather use the browser. And we could just put in Swift. I could simply put in Swift array. Let me make that a little bigger here. Do we see that? In my browser, I could simply say Swift array, press enter. And my first result is array from the Swift library. The same one we were looking at earlier, right? It's the same exact one, right? But it's just the online version. Whichever one you're comfortable with, go for it. All right, cool. All right, so some properties and methods on arrays. I'm very tempted to show first, but you know what? I'll show it. I will show it. It's okay. We'll see it again. We'll see it again until we're comfortable with it. So here we're using the first property. So first looks like this. So if let first planet equal to our planets array dot first. Okay. So here we're saying, stay with me on the right side of the equal sign. Let's focus on the right side of the equal sign for now. It says planets.first. That gets done first. Do not focus on the left side. Focus on the right side. Planets.first. Get me the first element. Everybody with me? Okay. Now let's focus on the left side. Get me the first element. Let's actually option click on first. If you option click on first, it shows you some string optional, correct? Right? The thing might be nil, or it might have a valid planet. If it does, with the if statement here, if it does have a valid planet, it will get assigned to our first planet variable. Everybody with me? So if this value here is not nil, assign it to first planet. So if planets dot first is not nil, think about empty for now, but not nil, assign the value to the first planet variable, or constant in that case. And as I said before, you could also have a var here, that's valid. But likely or not, you do not want to change the value. If you want to change the value, you make a var. If you do not want to change the value, keep it as a let. If let, okay? Everybody with me? And Apple always recommends default to let if you're not sure you're going to change that variable. You could always come back to it later, but default to let. Okay, so if it does have a value, do we get into line 67? If we do have a value, do we get into line 67? Yes, we do, correct? So if we have a value, we could continue our code here. So if we have a valid value of string, we enter this if block. How's what? The condition after the if. So the condition here is, think about the condition like this statement here. That's the condition. Right? So a mini, I want us to all think about the condition on the if statement. Focus on the right side. Focus on the highlighted portion of the code here. Focus on planets dot first. Focus on that being the condition. If this has a value, a valid value, it's optional. Remember, it's question mark. If it has a valid value, meaning there's values in there, right? If it's empty, it's nil, right? If there's a value, give me that value. That's the condition.
I understand the condition, but the way that it's structured is confusing.
Yeah, that's what I'm saying. Like the more we see that particular case, the better. That's why I want to show it again today, even if we also see it tomorrow. So if let my variable name, the variable name could be anything. Is declaring the variable. Well, we always do that, right? We always declare a variable first, right? For example, we could have a variable here, let, we could have a variable here, let weather, for example, right, equal to some variable, whatever, 75 is more than, 75 is less than, right?
Yeah, that's like a true or false. Yeah.
Right, so that's almost the same thing. That's what I'm saying, like focus on the right side.
So we should read planets not first as
As the first thing we're doing, as a true or false, right? So you could do that for now, until you get more comfortable. So Amini is saying for now she'll read planets dot first as true or false. False, I do not have a value. True, I have a value. Everybody with me? So planets dot first, it's a condition. Think about it as true or false now, as Amini is doing. But long term, we'll see it's either nil or it has a valid value. Okay? So true or false is pretty much okay here in that case. Think about it like that. If it's false, it doesn't go into the if. If it's true, it goes into the if. Okay? So this is good, Amini, I like that. So for now, We could actually write notes for ourselves and say, think about planets that first as being a condition of true or false, where if first does not exist, the condition is false. If first exists, then the condition is true, right? However, long term, we will come to realize that planets that first implies that either we have a valid value of string or not, in the case it's nil. That is, planets is empty. Planets array.
Is that the case for all members?
For all optionals. Yeah, optionals. Anytime you were getting an optional back and you want to, in that case, we are optional. Anybody remember what type of optional that is? Here we are using optional what? We saw nil coalescing, right? What type of unwrapping is this? I heard it. Wait, what's that?
It's the last one.
We take a value and we bind it to a next value. What is that? Binding, right? So optional binding. We'll look at it again tomorrow, but we looked at it last Friday. So here we are using optional binding to unwrap the first value. And here I just put question mark. So that's optional binding. In our projects, we are using optional coalescing, nil coalescing in some places. You could use nil coalescing here. Okay. Everybody got the notes? Yes, sir.
It would help me to understand this more if I saw what empty value or nil value in that array.
Yeah, that's fine. So we'll create one. We'll create one. Do we have a fellows yet? I think we have a fellow somewhere. Everybody finished writing? Go back, go down. We'll create an empty and see what that looks like. Just slack it out, he said. It's always better to write in that case. It commits to memory. So I'll take my time and let you guys write that one out. Scroll up, he said. Here. And let me take that down a little bit, I guess. Now we can see everything. What part? This one? Oh, in the long term. For now, we could think about it as true or false. And many saying true or false makes sense for her. If it's not empty, it's true. However, long term, we will come to realize that planets that first implies that either we have a valid value of a string or not in the case that it's nil. In the case that it's nil. So either it's nil or it has a valid value. One of the two options. Here, either we have a first planet or we don't. meaning either the array has objects or not. We'll see what it looks like. Are we done writing? Luba, we'll see an example. Examples are always better. So here, let's create an example. Let programming languages string annotation. Let's make this a var. So here we're declaring a variable, programming languages. It's an array of strings, and it's empty. Everybody with me? I will change my planets to programming languages. I will say first programming language here. I'll put an else statement here. Okay, so far so good. In my if statement, I will say print first programming language is first programming language. Else print looks like you haven't started using any programming languages. So we have a variable, it's called programming languages. We type annotated it. It's a type array of strings. We do not have any values in that array. It's empty. Now we're using optional binding to see if we have a first language in there. Everybody with me? So we're saying programming languages dot first. Get me the first programming language in the array. Okay? Get me the first programming language in the array. That's what we're saying here. Programming languages dot first. Dot first, get me the first element. Everybody with me? Get me the first element in the array. If you do have the first element, come in here on line 78 and print it out. The condition, if it has a value, print it out. Everybody with me? If there's a valid value, print it out. Luba? If there's not a valid value, come to line 80. Looks like you haven't started. Looks like you haven't started using any programming languages, right? Your programming languages resume is empty. There's nothing there, right? So looks like you haven't started programming. Oh, that's probably better. Looks like you haven't. That's fine, that's okay. All right, let's go ahead and run this. And in the console, looks like you haven't started using any programming languages. Did everybody get that in the console? Anybody want to explain why that happened here for me? See the same hands. Okay, Lydia.
There's nothing in the brackets,
Okay, everybody heard what Lydia is saying? There's nothing in our array. Our array is empty. Our array is empty. How can we get a first value in that bucket? Right? I got a gift for Christmas. I opened up my present. It's empty. I'm mad. I'm sad all day. I'm thinking of going to George Washington Bridge. Right? Hold me back, please. Right? Our bucket is empty. We have no destinations. Our bucket list or whatever is empty in this case. Our programming languages, we haven't started programming. We have nothing there on the resume. Right? So if it's empty, first is nil. So if first is nil, it doesn't go into the if statement. It goes into the else statement. Everybody see that? Great, perfect. But what if, we'll see append now, how to add. So actually can I paste? Yeah, I still have a header. Great. So here we'll see how to append or add to an array, or add to an array. So if we add an element to our array, let's see if it changes the print statement. So here I will say programming languages dot, right? Again, if we want to access anything on that API, it's dot. So here dot append. Look, it came up already. It know what I wanted. Actually, that's the first one in the result, right? So it starts with A, alphabetical. It lists all the methods and properties available. You could scroll, by the way, and see everything that's available here, right? Let's do it again. So backspace, delete, press dot, and append comes up. Do we all see that? It lists all the methods and properties we have on an array. I could scroll up and see what's available. There's end index, right, as we saw earlier in the documentation. Everything we saw in the documentation is here. Right? And as I said yesterday, if you see something with a strike through, don't use it. It's deprecated. Strike through means deprecated. So far, so good? Okay, cool. So let us start typing in append because we know what we're trying to do. So append, you start typing in append, and you see Swift is so intelligent. It knows the type of element we have. It shows us you're about to append a new element called string. Do we see that? If it was an int, this would be int. If it was a custom user that we created, it would be user. But here it says you're about to append a new element of type string. So let's go ahead and press enter. And our new element needs to be a string. We start out a string with 2 quotes. And in that string, we put our favorite language, Swift. Sorry, Matt, with a Python. Python is awesome. So now, let's run our application again. So make sure you have an append here. You append some language. Matt might put Python, right? And I'm going to run my program. And look, my first programming language is Swift. That's a good place to start. Scroll up, sure. Here? That's good? To here?
So you would do that. So you can do that anywhere in your.
As long as the variable has declared already, you could append anywhere after the declaration. And while we're up here, I want to show you something else. So I could declare my programming languages this way, or I could also declare my programming languages this way. Right? They're both valid. So here, both ways of declaring the array below are valid. Okay? So here is the same as up here, the same syntax. Okay? I'll tend to use this one more, right? But you'll also see that way as well. So if you see that, it compiles, right? So here you have your type annotation, you have your equal, and you have an empty square bracket. Implies it's empty. Here, you're using type inference. So actually, maybe I should say what we're using. So here, using type annotation. And down here, we are using type inference. Right? Anybody want me to go over what type inference is? Let's be open, please. Okay, so type inference, basically, I do not explicitly use type annotation. This is type annotation. I use type inference and let the language figure out what it is. But it is knowing what it is because in my array, I say string, right? I show what type it is. So far, so good. What else did we see? And let me scroll up for 1 second. I'll scroll back down. And we saw a third way to create an array where we had it earlier using, so this here is known as an array literal. Let's put that. So declaring, so scroll up to where we have our planets. Make your own notes here. Using or declaring an array using an array literal. Right? So here, that's an array literal. That's what it means. Literally an array. Very close to like a string, except we have the square brackets. Right? So that's an array literal. Okay. Wait. Wait for it. Okay, so far so good? All right, scrolling back down. Wow, people typed a lot already. Okay, let's see our optional again. Optionals, again, it's a bit harder to understand at first, but the minute you get it, you love it, and you really know why it's introduced into the language. So we started out with our programming languages. It's empty. We all agree that it's empty. We could even prove that it's empty. So here we could say if programming languages is empty, print, we need to start programming. Else print programming is fundamental. So here we're using is empty property on an array. So if we were to run our playground now, we'll see we need to start programming. Why do we see that? Because, why do we see programming, we need to start programming? Because it's empty, right? There's no values in there. We confirm that by using the isEmpty property. Everybody with me? We could also use count, say isCount equal to 0, but avoid using count for that purpose here. Use isEmpty. IsEmpty is faster. So we could also say if programming languages that count equal to 0, what are you waiting for? Question mark. Let's run it here. Right? What are you waiting for is still valid. But as I said before, isEmpty is more optimized. IsEmpty returns true or false. Count goes through every element and it counts it, right? So it's faster to use isEmpty to look for emptiness, right? So isEmpty is preferable over count. So isEmpty is preferable over using that count. All right. Yes?
Can you give us an example of when you would use like isEmpty and then append to it? Like why would you like say
Right now, we're showing you all the tools we have in our toolbox. It's up to us as we do our labs, especially the assignment, to use what we know and apply it, right? So an is empty would be, if the thing is empty, maybe you want to add to it in that case, but you want to check if something is empty before you remove something from it, for example. So that is empty becomes very useful. For example, if you're running a function and you're like, hey, as long as I still have bucket list items, remove them, right? But you don't want to remove without verifying that there's something to remove. So you could use is empty on it. Count, you have a theater or you have a concert and the maximum is 200 people. When I get to count 100, there's no more space, right? So you tell the user or the person buying the ticket, hey, I have no more seated, right? So you could use count there. Append, fellows are coming in, we have space, append more fellows to the class. Does that answer your question? Okay. Yeah. Same as your family. As your family grows, you append to your family, right? Good. All right, so we have append to array, great. We have, okay, so, yeah, scroll up. What line number?
We have the same lines.
Okay, what?
Two ways of declaring the array.
2 ways. Right here?
Or,
Down?
yeah, I just need to copy that.
Okay, like right here?
84.
84. Good? Good? Are you good now, Adam?
Yeah.
Okay. Everybody else good? Can I scroll down? Okay, so let's keep going down here. Okay, let's see how we remove items from an array. Nope. That's not what I want. Moving items from an array. Removing items from an array. And here we are using remove function. Okay. So let's verify how many planets we have, right? So print there are X amount of planets. So planets that count. Go ahead and run it. So there are 8 planets, right? Everybody, we still have 8 planets? Yes? Make sure we have 8 planets before we move on. Do we still have 8 planets? Great. What's that? With Pluto. That's where Pluto comes in. So we saw append. So we could say planets that append Pluto, for example. So there are 8 planets, right? How many planets are we going to have now if I was to copy this sentence and put it over here? How many planets are we having now? 9, right? So we had 8 to begin with. We appended Pluto, and Pluto is back, right? We have 9 planets. So far, so good? Scroll up. Okay, so now we have 9 planets. Everybody with me? Excellent. So here, we could actually print out what our planets look like. I could say planets here, print it out. It shows us all the values. We all see Pluto is the last planet, correct? If you say print planets on line 122, it shows all the planets we have currently, correct? And we have 9 planets here. But our science teacher is still saying we only have 8. Pluto is a dwarf planet. Regardless, he wants us to remove Pluto. So we have a built-in function called remove. We want to make our science teacher happy. So we say planets dot remove at some index. At some index. We have to pass an index here. If I want to remove the last item, what index am I passing? Right? So as Amin is saying, we don't want to hard code 8 in here. Right? That could change. You never want to hard code a number like that. So we have planets that count at our disposal. So we use it. So planets that count -1 gets us that last index. Everybody agree? So if we have 9 here, for example, we had 9 planets. And if we say 9 minus 1, we have 8. And 8 is that index that we need. Right? So 9 minus 1 gives us 8. So it removes this planet at the 8th index. And remove also returns. Let's option click on remove. Option click on remove. Anytime you want to see what the function returns or what the arguments look like, you option click on it. Anytime you want to know anything about a function or any variable, option click is our friend. Tell me more about yourself. So here, if we see it's a mutating function, we'll get into mutating, what that means. It removes some element at some index. Let me blow that up a little bit. Right? 1 second, get that here. Right? So it removes some value at an index. And do we see the arrow? Do we see the arrow? This arrow here. Do we see the arrow? We all see the arrow, correct? That arrow, when we get into functions, this says it returns a string. Right? So function name is remove. What's inside the parens is the parameter. It tells us the type. It expects an integer. The arrow here is what I'm returning. Some functions do not have arrow at all, meaning they're not returning anything. Like the print function doesn't have an arrow. It doesn't return anything. It returns void or nothing, right? But here, our remove function returns a string. It returns us not just a string, by the way, whatever element that we remove in here. In our case, it knows it's a string. That's why it shows us string. If it was an int, it will be an int. Yes, sir?
Since the arrow string isn't actually written in code, that's inferred because the data type in the array.
Let's go back to it and see and answer that question. So you mean it's not written here?
Right, like the example has the dash arrow, but we're not typing that out.
No, we're not typing that out. That's the function definition.
Okay.
All right? So when we start writing our own functions,
It's not really
exactly. When we start writing our own functions, we have to explicitly put the arrow if we want that function to return something. Yes, we have to write out that arrow ourselves. So we'll see functions. I think next week we'll start seeing functions. We'll write our own functions with our own arrow. Cool? And the heart of any interview is some function. Maybe it has an arrow or not. So like the heart of interviews is like, write me this function that does X. Yeah. All right, cool. So here we're returning something, and I won't get into it now, but I'll just briefly tell us. The function returns a value. You could tell your function, hey, if I'm returning something, the user needs to explicitly use it, or it's up to the user to use it. In that case, it's up to us to use the value or not, our option. But in our case, we want to use it, so I'll say let planet removed, or removed planet, better name, removed planet equal to. If you option click now on your variable name, you will see it's a string, right? You'll see it's a string. It's a string. Because this function returned us. It returned us a string, and the string now lives in this variable called remove planet. Everybody with me? And now I could put a print statement. I could say, looks like the removed planet right? So it looks like remove planet was ditched again, right? Let's see what the remove planet was. Right? So it looks like Pluto was ditched again. Right? Pluto got added, got removed, got added, got removed. If I was to copy my string that says there are planets, there are X planets, how many planets am I having now? According to Lilia, 8. Let's see. It's 8. We removed Pluto. It's no longer there. We started with 9 on line 122, right? Line 122, we have 9 planets. We removed the last planet on line 124. We have the removed value. We have access to it. We could print what was removed on line 126. And 128, we no longer have 9 planets. We're back to 8. So this is the power of remove. We could append, we could remove. Any questions? Very good. Okay. Let's see what random element looks like. You might want to use that for your lab, for your assignment. So random, so you're playing some game, maybe you want to learn about planets, and you want to get a random planet to get some information about it, right? Like you're quizzing yourself. Get me a random planet, and I'll tell you what the planet, what's the mass of the planet, whatever. Oh, hey, maybe that's an idea for a text adventure. So get me a random planet from my planets array. How do I do that? I just do random element. One more caveat, sorry. It's an optional. Optionals are everywhere, same. Right now, if we option click on random element, what type is it? It's a string optional, right? According to Greg? If we click on, sorry, Kelby, if we click on random planet, right? If we click on random planet, what type is it? What type is it? Click on random planet, what type is it? Jahid, what type is random planet? Option click on random planet. String question mark, string optional, right? If you, it's not an array, but the actual random planet here, the variable, like what type, what data type. So we option click on it, and we see it's a string optional, right? You see string question mark. Every time we see a question mark after the type, it's an optional. So here we have string optional. Brandon, what type is random element, random planet? String optional, right? So we have an optional here. If we print it out, let's go ahead and print what the random element is. Random planet is, we're getting there. So random, there we go. So now we'll try to run it. We have a warning. We know about warnings already. We need to get rid of warnings. It's like warning, right? Random planet is, what's random planet? Read it out. What's random planet?
Uranus.
I'm sorry.
Optional Uranus.
Right. All right, let's see if our randomness works. So run it again. We might be more comfortable now. What's our random planet? Read it out. Yulia, what's our random planet? I'm sorry? Jupiter. But what does the sentence read out? Random planet is optional. You show that on an app. That's not good user experience. Random planet is optional Jupiter. What does that mean? We need to get rid of that optional word there. Everybody with me? It returns us an optional string. The optional is in the string. We need to get rid of that optional word. Random planet is optional Jupiter. That doesn't look good on an app. If you see that on an app, it didn't make it through QA.
So this would force unlocking work here since we know it's a string.
Ah, fancy. See that? That's where we start to trap ourselves. You can force unwrap it.
But that's a bad idea.
In that case, that's fine because random element returns as an optional. But if planet is empty, what happens? Your app will crash. Because now you're saying you're guaranteed to get a planet. You bang it or force unwrap it, the app will crash. Because right now you're trying to force unwrap an optional that doesn't exist. There's sometimes where you want it to crash before you ship it. We'll get to that, right? Where you want your app to crash. We'll talk about what's known as compile time. Let's just put it here. We have compile time errors. And we have runtime errors. Right? Compile time errors, as the name is saying, when you compile your code, you have an error. Right? That's good because you could fix it before you ship it. Or you could fix it before you submit it to us for grade. Right? But a runtime crash, it compiles fine, everything is great. The user clicks on an image, boom, crashes. Bad. That's a runtime crash. You want to be able to catch a compile time error. So in that case, you could use a bang there. While you build, it will crash because the thing doesn't exist. Great. That's a compile time error, right? We'll get more into errors, but just keep that in the back burner for now. But if we bang, as Amini is saying, and we do not have any elements in our planet, the app will crash. But what is the next safety way? We've seen optional binding, right? What's the next way to, go ahead. No, yeah, double question mark. Double question mark, or the technical term is nil coalescing, right? So remember that for your recruiter or whoever's on the phone. Double question mark, we don't say that, we say nil coalescing, right? So very good, Mr. Matt here. So here we could say nil coalesce the thing and give it our earth. Right? Earth is the default value. We could set that default value after the two question marks, after the nil coalescing, to whatever valid string we want. In that case, if it's empty, it just returns us earth. So we're safe. So here we are using, as Matt pointed out, nil coalescing. So using nil coalescing, double question mark, we default to a value of earth. Okay? So now, if you option click on random planet, Yulia, what type is it now? Yulia? It's a string. The question mark is gone. Everybody sees that? Question mark is gone. It's no longer an optional. We run our application. We push it to the App Store. The user picks a random planet. And what they see on the screen is Random planet is Mercury. They do not no longer see random planet is optional Mercury. They see random planet is Mercury. Yes, sir.
So it only like Earth if there's nothing there.
It does nothing there. So if we, bear with me, Adam wants to see what happens if we do not have anything in our planets. Actually, let's stay right here. Let's see something else. I want to empty out my planet. Where's my thing? Remove all. Look at this guy flying around. Looking ahead. Very good. Okay, so we want to see what's happening here. So let's go ahead and remove. We saw remove here, but remove all elements in an array using remove all. Right? Remove all. Get rid of all the planets. Well, in the case our poor solar system is gone, right? Okay, so we could use this right here. We could say planets dot remove planets. Remove all. So remove all. Right now, what's our count? Print. There are X amount of planets. There are planets in the solar system. And here we say planets that count. Run our playground on 137. Yes. So look, something bad happened. We have no more planets, right? Scroll up to what line? 30? Oh, almost blew my heart out. Here, like right here, okay. So here we use a next built-in method. It's called remove all. It removes all the elements in the array, right? Removes all the elements in the array. So now we're back at 0. So here we're at 0. Either we are the beginning or the end of the universe at that place. All right, so here's 0 planets. And as Adam was trying to point out, what happens if we have no planets? Can we scroll down? Okay, so if we go down to our random planet here and we run, what's the expectation here? On 139, random planet is, let's see, play. So random planet is Earth. It defaulted to our nil coalescent value because no longer this guy is nil, it's false. It looks at our default value after the double question mark, after the nil coalescent syntax, and it goes to Earth. Right? Maybe we just say planet X. Right? So that default value has to be a string. Regardless of what you put in the string, it has to be a string. It can't be an integer. As we said earlier, Swift is type safe. If you are giving our random element a default value, in that case, it's expecting a string. So here we have random planet is planet X. Cool? So random element is great on your array. Very useful for your projects if you have to have some like random element like a card. Maybe you have a card. Pick a random element from it. Great. Let's see what pop last looks like. Pop last, as the name implies, pop the last element. Remove it. Remove the last element. So instead of saying remove, bless you, instead of saying remove count -1, I could say pop last. Now in that case, think about it. You're the one writing that API. Pop last, what should it return? Should it return an optional or should it return a value? What should it return? Value, value. What should pop last return? Should it return a value or an optional? Or an optional? Pop last, like I want to remove something from the last element. Optional would probably be best, right? Let's see what Apple did. So we have our planets dot pop last. I'm starting to type in pop last. I'm already seeing it's an optional because there might not be a value there. Anytime there might not be a value, you want to declare your thing optional. We'll see it the more we write code, right? It's like a photo. Not everybody wants to have photos. IAs. Not everybody wants to have photos on their Slack profile, right? There's no guarantee there's a photo. That might be optional. It's up to the user. Do I want to add a photo on my Instagram? Maybe you do. It's Instagram, all about sharing photos. But there's the one user that don't want to have a photo on the Instagram. So maybe we make it optional. Here, we're saying pop last. There might not be no value in that bucket. How can I pop things if there's no value? So if I'm popping last, it should be an optional. It should return optional. We'll see more of optionals. We love optionals. All right. So here, pop last, it returns a value. Here, we will say, oops, another planet. It's gone. Re-add the planet? Right now, we're just removing planets. Right now, we had, I haven't re-add them. So that's a good point. So what's the expectation there?
Yeah,
It's still empty. So we'll re-add them by just comment out. Many brought up a point here. Let's just comment out for purposes of demonstration. Keep your remove, but just comment out the remove all. Make sure you comment out the remove all, everybody. Where it says planets remove all, that works. That's how you remove something. But now we want to keep all our planets. So far, so good? So make sure you comment out planets that remove all. So now we still have our 8 planets, and let's keep going down. And here, pop last also returns an optional. Eddie, come and complete this for me with nil coalescing and give it a default value. Yes, sir. So using nil coalescing, give it a default value and print out the planet that was actually removed. So print out, oops, another planet is gone.
So you want me to print out this guy? The guy who's gone?
Yeah.
What
For here, you give it a default value. So just give it whatever default value.
Oh, it's the same thing?
Yeah.
Line was gone.
Okay, and then print, use a print statement to print out what planet was removed. And use string interpolation for the oops and the planet is gone variable.
Okay, so you want me to print. What do you want to print?
Like another planet is gone,
Okay.
and using string interpolation, another planet. Cool, right?
Okay.
146. Cool, so it looks like Neptune is gone. Thank you, sir. So good. The more we use nil coalescing, the more comfortable we'll be with it. But basically, that's the use case for it here, especially you pop in some value that might have nil in there. So we give it a default value of, in that case, planets is gone. That's fine. But you could give it like some sort of name. Yes?
In this case, if it was empty, wouldn't it print
It would print the planet was gone. That default.
Instead of oops, another planet.
Yes.
So,
So it would print another planet was gone, the planet was gone. Okay? So here, let's, so for example, Amini's planet, right? Right? If you want to see that printed, we could simply say planets here, remove all, correct? And run it again. And we'll say another planet was gone, a mini planet. Right? Cool? Assuming it was empty. If it's empty, it defaults to the default value. All right, but comment that out. Okay, cool. All right, let's see modifying arrays. We're doing good here. Please go. Oh. Modifying arrays. Get a new title, a new header, so we could make our code look better reading it. And let's go and add a new topic. Our new topic is modifying arrays. How we doing? Anybody wants it slacked? Shout at me, guys. Don't wait for me to ask. Okay, let me slack what we have. Create arrays version 2. All right, it's out on the slacks. All right, modifying arrays. I'll wait for you guys to get updated. Give you a couple seconds to paste the code in. So we add modifying arrays. We've seen append. That's fine. What I want to show us is adding arrays together. Everybody up to speed with the code I just slacked? Yes? Okay, cool. So let's create some arrays here. Classroom 1 or 2 here. Classroom 2, some array. This is an array literal, by the way. So the minute you start with the square brackets and you put the elements in, it's an array literal. So here I have Aaron, I have Jack, I have Vic, I have classroom 1, I have Margaret, Mr. Greg, and Adam. So far, so good. We have 2 arrays. What types of arrays are those? Arrays of strings, right? So far, so good? Okay, awesome. So I want to go ahead and add those 2 arrays together. So add in, or you could say concatenating arrays together. Now they need to be of the same data type, very important here. Note. Adding arrays together. When adding arrays together, they need to be of the same data type. Cool. So they're both mutable, that's fine. We could add stuff to them. We could change them. So here we'll say classroom 1 plus equal classroom 2 In this case, what's the count of classroom 1? On line 59, what's the count of classroom 1? Bienvenido? 6. Greg? The count of classroom 1. At 159. If we were to run the code at 159, how many items does classroom 1 have? Yeah, how many items would it have without running the compiler? How many items? 3 items at line 159, right? But notice what we did. We said classroom 1, go ahead and add classroom 2 to yourself. On line 158, right? We added the contents of classroom 2 to classroom 1. So what's the count of classroom 1 now? 6. Everybody sees that? Right? So here is very similar to what we've seen with whether it be string concatenation or adding two numbers together. We add in the two arrays together.
So it's not going to count from 0 and then 1, 2.
No, but the count of it. Like what would classroom 1 that count be?
Okay.
Right? So let's see. So print classroom 1 has X amount of fellows. So classroom 1 has classroom 1 dot count. Right, and go ahead and run it, 161. Right, so classroom 1 now has 6 fellows. Everybody sees that? On line 153, classroom 1 has how many fellows? 153, how many fellows? 3, correct? On line 158, we're like, hey, go ahead and combine the two classes together. So classroom 1 now has 6. How many fellows does classroom 2 have? We agreed 3, correct? We haven't changed how many fellows classroom 2 has. Right? So now that's why we have to start really reading the code and see what's happening. 153, we declared classroom 1, it has 3 fellows, that's good. 154, classroom 2, 3 fellows, still good. 158, we're making a modification to classroom 1, not classroom 2, right? So the modification happens on the left side of the equal sign. Everybody sees that? Classroom 2 doesn't change. I only combine classroom 2 with 1, but 1 changes. Right now, classroom 2 is the same. And I say classroom 1 now has 6 fellows. So here we could add similar types together. But I wouldn't be able to do this. I wouldn't be able to say, you know, some integer like this, right? That's an array, that's a valid array. But the compiler says, cannot convert value of type int to expected type string. Type safe, protecting us from ourselves. You cannot add a string array with an int array. Does not compile, right? Does not compile. Not add different array types together. Right? But this is valid, what we did earlier. You could do classroom 1 plus equal classroom 2. That's valid. They're the same type. Everybody with me? Same type, you can add them together. Different types, you cannot. Okay, let's see iterating through an array, our favorite context topic. We love to iterate through things. No. Keep losing my headers. So get a new header, copy a new header. We'll talk about looping through arrays. We've seen that before, but we'll see it again. Iterating. Or looping through arrays, right? Good. Should we create a new one? Maybe we should. Okay, that's fine. So we'll keep using our planets for now. We'll use different methods. So this is going to be method 1. Iterating. Iterating through array. Okay, so we have our for loop. Our for loops are very powerful for iterating through an array. We'll say for planet in planets. Yulia, I know it's hard on the eyes for now, but you'll get more used to it. Where you see planet in planets, right? I could say for item in planets, but it's really a planet, right? So the planet is that one item. So for planet in planets, the planets is our array. So for planet in planets, I only want to just go ahead and print what the planet is. So for planet in planets, well, let's give some more, a better name here. So planet name is planet. So iterating through array using for in loop without using an index. All right, here we have no index. We don't care about any index. We're just printing out what the element is. In that case, the element is a planet. So we're saying planet name is X. So let's run that and see what that looks like. So here we have our planets getting printed out. Planet name is Mercury, and so forth. Maybe just take out the name. So planet is Mercury, Venus, etc., etc. Right? So we have all our planets. They got printed out. Oh, we missed our last planet. Neptune disappeared. Let's bring back Neptune. Actually, it's fine. You know where Neptune is, somewhere. Okay, that's method 1. Let's see what a different method looks like. So method 2, iterating using enumerated to gain access to the current index in the for in loop. So the first method, we didn't care about the index. We are not using enumerated. We just want to print out what the element is. What if you want to print out what the index is, the current index? How do you get access to that? We've seen it before. We'll see it again. On any collection in the for loop, you could say dot enumerated. It gives you access to index. So now we could say for open parens, the variable name, we'll use index, right? Our planet name, again, those are just variable names we have here without explicitly saying var or let. In the collection is planets. Don't forget the dot enumerated. So this is good. So now I have access to index. What does index start at? At 0. So now I could use my index to make my print statement look a bit better. I could say planet index I'm making use of both planet and index. It shows me the planet and it shows me the number. But the number starts at 0, doesn't make quite sense to us, planet 0, right? So now I could say index plus 1. So it starts at 0, I could do anything now with the index. I could say planet 1, in that case, Mercury 1, right? And so forth. So let's see what that looks like. Right? Mercury 1, Venus 2, Earth 3, Mars 4, Jupiter 5, Saturn 6, Uranus 7. I'm missing. Yeah, let's add it again. We'll add it. Yeah, let's just add it. Let's add it here. So let's add Neptune again, guys. We missed Neptune. So planets, anywhere above, just put planets, dot append. Actually, let's show something else. No, that's fine. In the same block, like down here? Like here? Okay, let's do it there. Thank you. So we'll do planets, dot append, and bring back Neptune. Neptune, come back to us. Okay, so we're adding back Neptune, so we have Neptune here. And go back and rerun your playground. Cool, so Neptune is back, right? So now we're using the index. So if you want to use the index, you use dot enumerator. Yes, sir?
Does append revert to where we first used that?
It adds it at the end. Good question. It adds it at the end.
So no matter if you took out Mars would be
Yes. So as you append, good question. When you append to the end. Right? In the array, you always appends to the end. You on a movie line, I say append new person. You're not going to jump the line. Right? You could explicitly put what index you want to add it in, or you could say append. Append goes to the end. Exactly. If I want to overwrite, yes. Oh, sorry. Oh, right. Yeah. If we don't get to it today, tomorrow we'll see how to override a position. So if I want to say Mars, I could change the name Mars by explicitly saying subscript and change that name. We'll see that tomorrow because we're coming to an end very soon. Yes, sir?
Can you explain the
Index plus 1. Okay, let's see. You guys good? Can I scroll down? Okay. So Adam wants us to go over the index plus 1. So index, if we remove, let's see what it is remove first. So if we go ahead and remove the plus 1, the output will be planet 0, planet 1, right? But we want to start counting from 1. So let's look at the console. It says Mercury is 0, correct? Everybody sees that? From the point of view of a human being, we do not count from 0. We count from 1, the first, right? So here, our array index starts at 0. In our string interpolation, we could do anything we want. So now we could say, but does that answer the question?
I think it does. So you're saying when you add the plus one, it adds an invisible space.
Not a space.
Oh, I get that.
To that number, if the current number is 0, 0 plus 1 is 1. If the current index is 1, 1 plus 1 is 2. So that's all just for like visual appeal. Okay, everybody? That's a visual appeal there for the user, for the planet person, for the user of our application to see, hey, the first planet is Mercury, not 0. We didn't learn to count from 0. So here we could just say plus 1. Right? Cool? Very good. Any other questions? Let's see the third method, and we'll close it out there. Did I see a hand?
Yeah, I was just curious, why the for loops
to green. What
Like when it's printing,
when it's printing?
you can all
Oh, that's just for us to understand what its type. That's syntax highlighted. It will print everything as white text, but for us to better understand what, like for example, the keyword for has a special highlighted color, very similar to the var keyword, right? Our own variable name is blue or green here, right? You could change those. That's more like an Xcode preference if you want to change your syntax. I've seen purple everywhere on some screens, right? It's up to you.
So the four is what?
The for is a keyword.
Yeah, but the items that are in four are white.
Yeah, those guys are not. Those guys are variables, so they're white here. But this one is our own custom variable that we declared further up, so we have access to it. Does that make sense?
Yeah.
Okay. And same as like planet is just a variable that same planet we have. Cool? It's not gonna get printed in that color.
Yeah.
Yeah, cool. I know you want colors. We'll get colors. It's coming. Okay, so method 3. Yeah. Oh, 2 minutes. One more method. Yeah. I'll join you guys. So for index in 0 ... our favorite range syntax, planets dot count. Okay, again, we have index here. It's the same. It's a variable name. I could have I could have current index, but index is just some variable name. And this is a different way to go about printing the elements. We could use the range. We start from 0 because we know arrays start from 0. We use planets.count as the count of the elements. But here, very important, it has to be a half range. If we put a full range, the app is going to crash, correct? So we have to exclude that last value. Okay? And here, we could go ahead and print. Here, we could go ahead and print our planets, very similar to the enumerated at the current index, but actually different than the enumerated. Here we actually have to subscript it using this index, right? Slightly different. Here we just print out what the planet is. Here we have to use indexing because no longer are we using planets by itself. We overrode the default behavior of the for here, and we are using a range. So method 3, using a range. So here we're using a range. There's use cases for it. We'll see more of those as we keep developing. But there's use cases where you want to have that sort of range to have access to the elements. Okay? So that is going to end. Do you have any questions? Yes, Julia. So if we do full range, it includes planets.count. Right? Planets.count is what? What's the value of planets.count? It's 8. So if I say planets index 8, what happens? If I say planets, let's actually run it, right? Right? It's going to crash. Let's go up and see why. Remember 8 in your head, okay? We'll go up to 8 and see what's happening. So if we go back to planets, where we have planets here, where we first declared planets. Planets is a long way ahead into the distant place. Okay. Yulia, are you with me? So we first declared planets here, correct? Okay, so let's count. 0, index 0. 1, 2, 3, 4, 5, 6, 7. So far, so good? There's no 8. If we say index 8, app crashes. Index out of range does not exist. That's why if we say count, in that case, count is 8, and we try to use square bracket 8, in that case down here, right? Because every time, remember, every time the for loop goes inside of the loop, it increments the index. So if we say planets.count, if we include 8, 8 gets replaced with index here, app is going to crash. Cool? That's why we have to be very careful here and do not include planets.count. So here we go into less than planets.count, which is 7. Very important. Cool? Any other questions? Okay, very good. So this is part 1. Part 2 will be shorter. We'll end part 2 talking about multi-dimensional arrays. So please read ahead a little bit. Actually, read today's lesson. Today's lesson is talking about multi-dimensional arrays. Tomorrow we'll see how to access multi-dimensional arrays, and we'll end it there. And then we'll talk about optionals. Cool? Very good.